Okay, yet another time, speed, and distance question. In this problem, we have a motorbike leaving point A at 1 p.m. and moves towards point B at a uniform speed. Okay, so the motorbike starts from this point A, let's say, at 1 p.m. and travels towards B. Okay. Car leaves point B at 2 p.m. Okay. So when the car starts at 2 p.m. From this point B and moves towards point A. Okay. So in this direction, it by this much time and at 2 p.m. the motorbike should have already traveled a certain distance, right? So the motorbike is still traveling in this direction. Now moves towards point A at a uniform speed, which is double that of the motorbike. So the car is traveling with a double the speed of the motorbike. I'm not denoting these with variables as of now. Just let me keep a mental note of it. It's a very simple data to remember. Now they meet at 3:40 p.m. Okay, so they meet at 3:40 p.m. somewhere. Now, obviously, this will be a little closer here because the motorbike is traveling with half the speed of the car. So these two distances will be in the ratio 1:2, of course. So this is 3:40 p.m. So let me keep a mark of that as well. And at a point which is 168 kilometers from A. So this entire thing is 168 kilometers. Great. Now we're looking for the distance between A and B. Okay. So let us do something. We have these three segments. Let us try to relate these three segments. Now, the first thing, the first segment and the second segment, both of these segments have been traveled by the motorbike, right? Now, let me say this is segment one and this is segment two. Just denoting it in this way so that you understand what am I doing. So the segment one and segment two, this has been traveled by the motorbike. Now, motorbike has not changed its own speed, right? Hasn't changed its own speed. So this part of segment one, the motorbike has traveled in 60 minutes, and this distance has traveled in 100 minutes, right? So 60 minutes plus 40 minutes, so that is 100 minutes. Since the speed is constant for the motorbike, so we can say that the distance would be as good as this ratio. So the distance of the segment one and segment two should be in the ratio 3:5. So this is the first thing that we obtain. We can immediately incorporate this 168, but then I'll do it in the last stage. Okay, now the segment three. Now, what we know is the motorbike was at this point at 2 p.m. and the car started from B at 2 p.m., right? Now, after this, the car and the motorbike were traveling with a speed of 2:1. So, car being 2, motorbike being 1. Now, since they have traveled the segment 2 and the segment 3, so let me call this segment 3, the car by segment 3 and the motorbike by segment 2 for the same time period. So we can definitely say that the distance ratio in this case will be equal to the speed ratio, because the time period of travel, both of these are in 100 minutes for the motorbike as well as the car. That is the time is constant, so the distance ratio would be as good as the speed ratio, right? Now, since the car is traveling with double the speed of the motorbike, and for speed for this segment two, we have already considered 5 as the part. So I'll simply connect this with a 10. So now we get a combined ratio directly, right? So now we know the relationship. So if this entire thing, the segment one plus segment two, that is 8 parts, is actually 168 kilometers. What are we looking for is the entire distance A to B, which is segment 1, 2, and 3 combined. So that is 18 kilometers. So this is what the question is asking for. How much is the 18 parts corresponding to, right? So you can directly do this as 21 into 18, or what I'll do is I'll just figure out this 10. That will be easier. So 8 parts is 168. So each part is 21 kilometers. So 10 parts should be 210 kilometers, right? Now, since 8 part is 168 and 10 parts is 210, so the 18 should be sum of these two. So that is 378 kilometers in this case. That is the answer as option B. So I hope this was understood. It's a very simple problem in time and distance. So this is the reason I always recommend in our classes to our students to draw a diagram. If you draw the diagram in time and distance problems properly and you relate the scenarios properly, so we have uploaded very recently a video on our YouTube channel regarding this basic idea of time, speed, and distance, how to do the scenario analysis, and how to best use the proportionalities. It's a very, very detailed explanation. I hope you can, with proper illustrations and everything. So I hope you watch that video. You'll get more clarity into it. So there are some good examples also explained. So this is a very, very easy problem if you have a habit of solving time distance problems in this way. But I'll still put somewhere around 1.5 minutes, an ideal time to solve this particular question. It should never take more than 2 minutes. It definitely should be solved within 2 minutes. But let's say around about 1.5 minutes on an average as an ideal time would be good enough time in which you can solve this question. You might even solve this in a less than a minute or something. So that's it for this question. I hope you enjoyed this. Thank you.